Hello, this is an introductory video on mathematical induction. Proof by mathematical induction is a method of proof in mathematics. Proof by math induction can be used, for example, to prove this statement, that if you're adding up the first n integers, the sum is n times n plus 1 over 2. We're trying to prove statements to be true for all natural numbers. In other words, it doesn't matter if n is 50, 100, or a million, it's going to apply in every case. Here's another statement that we could prove using math induction. So let's look at the principle of mathematical induction, sometimes called PMI. For every natural number n, the natural numbers are the counting numbers 1, 2, 3 up to infinity. Pn is going to be a statement, and that statement is, of course, going to be true or false. The principle of math induction says that if we have two things to be true, P1 being true, the statement number 1 is true, and if we also have the statement if pk is true, then pk plus 1 is true for every natural number k, then the conclusion of PMI is that the statement Pn is true for all natural numbers n. I want to take a quick peek here at the mathsisfun.com website. They say that mathematical induction is a special way of proving things. It only has two steps. First of all, you show that the statement is true in the first case. Then you show if it is true at any point, the next statement is true. And our conclusion will be that they are all true. This is the domino effect. We must first establish that the first domino is falling over. Then we establish that the dominoes are close enough together that when any domino falls, the next domino falls. If we know these two steps, we can conclude that all the dominoes will fall. We do have one variation of the principle of math induction. Sometimes it isn't true that if you have statement number 1 is true, but it starts being true at a particular value. So this is a slight variation. Once again, Pn stands for a statement. The two things we establish here is that there's a starting statement that's true, Pm, maybe that's statement P5. And then if Pk is true, then Pk plus 1 is true. And we make the conclusion that the statement Pn is true for all natural numbers n greater than or equal to m. Now I'd like to look at the form of a proof by mathematical induction. But before we do that, I want to recall two hard and fast rules about writing proofs. First of all, you start your proof with the word proof. Secondly, the last line of your proof should be what you're trying to prove. As we're taking baby steps writing proofs, we need to do some of the basics. It's kind of like starting a sentence with a capital letter and ending a sentence with a period. So what is the form of a proof by math induction? There are three parts, and we're going to use Roman numerals for the three parts. Roman numeral 1, you establish that P1 is true, and these dots means there's a little bit of work to be shown there. It's usually pretty trivial, but if you don't knock down the first domino, nothing's going to happen. Part Roman numeral 2, you start out by stating your given information, which is Pk. Oh, I have a mistake. Hold on here. There we go. Our given information is that Pk is true, and we're trying to prove Pk plus 1 is true. This is a little mini proof inside of a bigger proof. In fact, this is a direct proof, starting with the given information, and the last line of this little part 2 here will be statement Pk plus 1 being true. And finally, Roman numeral 3, you state by PMI, and then you state the statement that you are trying to prove. In my next video, I'm going to do an example.